We wanted to build spaceships that could matter, to create a transportation infrastructure for the industry, for humanity,
Welcome to Third Angle, where we find ourselves in the mission control center of a major space operation. I'm your host, Paul Hames from industrial software company PTC. In this podcast, we share the moments where digital transforms physical and meet the brilliant minds behind some of the most innovative products around the world, each powered by PTC technology. Whether it's improving the way we navigate the world through GPS or making it possible to pay for our groceries from anywhere in the world, satellites have become an essential part of keeping our modern lives running. But up until fairly recently, launching satellites into space was a bit like throwing a stick into a river and waiting for the current to take it on its natural course. That is to say, it wasn't very accurate. That was until ION, a satellite carrier which solves the problem by delivering satellites exactly where they need to be, putting them into the correct orbit faster and more efficiently than ever before. And it's an innovation from space logistics company D-Orbit, a customer of PTC's Italian partner, Deda Group Business Solutions. And it means satellites can begin their essential work in a matter of days instead of months. Lorenzo Ferrario is D-Orbit's CTO and employee number one. He helped to invent and design ION, and our reporter, Jonathan Zenti, met him at the company's HQ in Italy.
Okay, so this is our mission control center, basically the bridge of our spaceship. The desks, as you can see, are organized as the bridge of the Enterprise. What you can see on the wall are two big screens where all the orbits of our carriers is projected, where you can see in real time the position in space of our 6 flying spacecraft and the status of all of them. And indeed, here is where all the critical operations are executed, like first acquisition of signal after launch, payload release generally, or critical operations during the mission. The positions here, just on my back, this is called the captain position, is where the director of the orchestra sits. Here in the front there is operations, which is managing the operations of the spacecraft, so basically sending and receiving commands, and especially everything that is related to attitude. Flight control, which is managing, again, telecommands and telecommands, is like the helm of the ship. Engineering and then communication, of course, they do what they say they do. Engineering is for monitoring the status of the spacecraft, and communication is to monitor the status of the ground segment, because satellite is just as good as your link to it. So it's very important to monitor in real time what happens on the stations, so on the antennas that we have on the ground. The orbit started in 2011, so it's 11 years this year. I mean, I can say it now. It was crazy at the time, but now I can say it. So we wanted to build spaceships that could matter. So we wanted to build a logistics infrastructure. We wanted to create a transportation infrastructure for the industry, for humanity. In the sense because we believe that transportation, so building roads, is the first thing that you need to do if you want to expand. So we started from there. That was the founding idea. So ION is our full name is ION Satellite Carrier. Is a very special spacecraft. I don't like to call it a satellite, because a satellite is something that flies on an orbit, stays on that orbit for the whole life, and then is removed. While ION is designed not to do that, it's designed to move. It's designed to be an agile spacecraft that goes. Is a transportation mean. So you can imagine it as a last-mile delivery service that is taken to orbit by big rockets, sometimes even multiple IONs at a time, like is going to happen in the next mission. ION is loaded with the customers, which are by themselves the satellites or other payloads, and by using its own propulsive means, once in orbit, ION moves from orbit to orbit, releasing and delivering, in the end, our customers, which again are satellites and other payloads, to where they have to go. So we are in the orbit's clean room. is basically where we like to say the magic happens. So where we turn bare metal into spacecraft. What we are doing right now is we are dressing up. So we are dressing up with coats, hair nets, beard nets, and shoe covers to get inside, because inside the air is very clean. We don't want any dust to deposit on optics, to deposit on hardware components or actuators or mechanisms, and so the air is maintained clean in a clean and temperature control and humidity control environment. It's very common in the space industry. I would say it's pretty mandatory. So we're about to enter now. Okay, here we are. Okay, so this is our clean room. It's divided into sectors. It's been reorganized several times over the last few months to accommodate an ever-growing line of production. Right now we can accommodate 15 carriers per year as a rate of manufacturing. What you can see right now are 3 carriers in manufacturing stages. Manufacturing is organized similarly to automotives, so without isles and with the carriers, so the satellites, they move along the production line to the various stages. And once they are finished, they exit from that door, which is called the airlock, and they are shipped away to the launch site. At the moment, we have said 3 Ion in manufacturing here, and other 2 which have been completed, and now they are on their way to Cape Canaveral for a launch in the next few weeks. Okay, if we move a little bit here on our left side, what you see here, these big bottles, shiny bottles, these are the propellant tanks for our propulsion. So one of the big advantages, and actually one of the selling points of our carrier, is the capability of conducting orbital maneuvers. So once it's in flight, it's released by the launcher, it has its own propulsion system, its own thrusters, so little rockets that move up, and they can move the satellite, our carrier, up and down and reach the final orbital destination of our customers. And of course you need the fuel, right? You need propellant. Actually, you need much more oxidizer than fuel. And so what you see here is the tanks for the oxidizer, and on the other side you see the tanks for the fuel. When it's the launch day, is always a little bit of a strange day. Generally, launches happen at strange times, so most of the times they don't happen during work hours. So generally, a launch day goes like this: that you wake up, you go to work, you don't work all day, because if you try to work but you can't. So you don't work all day. Then, since at least most of the launches that we did so far happened during night, say a good number of people from the company stay in office. We go out for dinner together, and then we meet for the launch. And then, I mean, even if it's the 6th or 5th time to see a launch, is always a little bit of a stress, because you can imagine that you have your months or something. When it's the first time, years of work that are placed on top of a barely controlled bomb that is barely exploding controllably in a continent far away, and everything happens in 10 minutes, it's a little bit of stress, and I don't think you really can get used to it. I mean, I am not ashamed to say that I cried a few times. But then, of course, then it's like the team, the soccer team at the day of the match. There is the operations team. For that day, they are focused completely. They're like in a Zen state, which they don't go to work. They just come for the launch time, because they have to be rested, of course, and prepared to take over operations. Because what happens is that we follow the streaming from the video that the launch provider give us. We follow the launch, and what happens is at some point, few minutes or sometimes even an hour after the takeoff, the liftoff, our carrier is released from the launcher. When that happens, the carrier turns on, because the switches on the carrier tell the computer that the release has happened. So everything is turned on, comes to life. And so the satellite, the first thing that it does is it looks for the sun, because it's powered by solar panels. So sun is life. So it stops any kind of tumbling that was induced by the separation. And then after that, it starts calling ground. So it starts opening a radio connection, a radio transmission, which we call the beacon. So every few seconds, it sends I'm here kind of message. And the first time that it passes over one of our stations, which again maybe minutes or sometimes even 1 hour after the launch, you have again what is called the acquisition of signal, so AOS. That is the tensest moment, and I have goosebumps just saying it. It's basically you can imagine that everybody that is at that time, which is generally nighttime, I don't know why, but it generally happens during night. Everybody that is in the office goes there on the back of the control center, just outside the windows, and the team is in the control center, extremely focused, especially on the comm position, because the comm is where you see the spectrum as recorded by the antennas. And the only thing you can do at that moment is just wait and see if the spacecraft calls on. And again, goosebumps. As soon as you get contact, as soon as you recognize the signal, the dance happens. So you start sending commands, you start receiving telemetry, and at that point you verify how the satellite is. So if everything is well after a launch, and you start what is called the commissioning of the spacecraft. The commissioning is basically the beginning of life. But again, even if I'm my 8th launch, still goosebumps even just telling it. So I mean, you realize that engineers can cry. So. Well, the future of space industry is I would say very bright, and it's very exciting. So we have seen happening things that we never thought would have happened ever. I remember very clearly the day in which I've been given a mathematical proof by doing a lecture at the university that landing a rocket was not possible or not convenient. And I remember very clearly the day in which a certain company did land a rocket, and now it became a routine. It's literally routine landing a rocket vertically on a ship, on a barge in the middle of the ocean, 600 kilometers away from the launch pad. So, which is crazy. All of these things were not. This is just one, but over the last 3 years, we launched more satellites than the last 30 years combined. So again, this was also something that was not thought possible. So it's very exciting. We are in a situation in which there is a lot of different solutions to the same problems. So it's also very exciting because you can have, this is where creativity matters. And so it's very exciting because you can literally see the effect of the choices that you make, not just on the products that the company makes, but also on everybody else. So how we designed Ion conditioned our competitors design their own carriers, and this in the end conditioned how constellations have been designed around that service, and basically in the end they conditioned a lot of the current landscape. And everything started from a decision that we took in 2018, for example, and we were like 20 people in 2018. So you can really, really see the effect, not just on what we do, but on what everybody else in the world is doing. So that's extremely exciting. In terms of possibility, I believe that we are in a stage of the space history in which we are transitioning from a phase of exploration, which has been everything that has been in this industry since 1957 to now, into a phase of expansion, in which we go to stay, and now we don't go to come back and then go somewhere else. This is a huge step, because it means that the space is no longer seen as a frontier of go, peek, and come back, but it becomes a place where you can go and stay. So it becomes one of the environments of humanity, just like sea, air, and of course ground. So I really do believe, and I'm really convinced, that we are in the generation that will see life extending outside Earth, that will see the rise of basically the normalization of space. We will stop talking about space as we do right now, and we will start talking about space as we do for aircraft, for example. When space will become boring, it will mean that we've done a good job.
That was Lorenzo Ferrario. CTO of D-Orbit. Now, each of D-Orbit's clients has different requirements, so its missions are never identical. To make sure they can adapt quickly to client requests, they need software which models the final product in a fast and efficient way. That's where PTC's 3D computer-aided design software Creo comes in. Let's find out more. Time to meet our expert, Brian Thompson, who heads up PTC's CAD division. So, Brian, we've discussed the merits of Creo in previous episodes, but can I ask that you give the listeners a quick reminder as to what Creo is and how it helps manufacturers in industry today?
So, first of all, Creo is PTC's flagship 3D CAD solution for the market. And I would say primarily the reason why customers started moving to 3D CAD 30 years ago is simply because until the invention of really scalable, commercial-ready 3D CAD, design engineers had to, for lack of a better term, imagine the third dimension of their designs. They were doing everything in 2D, and frankly, the level of additional comfort and confidence that design engineers get by being able to completely define their designs in full 3D is really hard to underestimate. I mean, it is extremely valuable to have full confidence in your designs in 3D to make sure those designs can go together as the manufacturing team starts to assemble them, to make sure those designs are manufacturable as the manufacturing engineers decide how to apply, say, NC toolpaths or injection molding processes to those parts. The fact that the model is fully defined in 3D gives rise to all of these other design checks, manufacturability checks, serviceability checks, because you now can evaluate designs in ways that customers never could before. And so 3D CAD, the process of defining your designs in 3D is really fundamentally giving customers the full capability of evaluating that design from sort of every respect in the value chain, from every point of view in the value chain. And I think that is why 3D design is frankly stuck and is continuing to grow remarkably in the world of discrete manufacturing.
I certainly remember my early experience with 3D CAD with Pro Engineer as it was then, Creo as it is today, and it is that ability to see what you're envisaging and know that this is exactly what's going to get manufactured. I still think that is one of the most powerful things, and Creo's ability to capture whatever it is you need to model, that I think, again, is one of its fundamental strengths. Now, we've heard Lorenzo talk about the time sensitivity of launch dates for D-Orbit. So help me understand, how does Creo help them meet those tight deadlines? What is it we're doing? What is it they're doing to enable them to meet the deadlines?
It's good that we started with a definition of 3D CAD because, frankly, for D-Orbit, they have a pretty significant challenge because, first of all, their assemblies are very large. And the complexity of bringing together hundreds or maybe even thousands of parts into particular modules that then get stacked together into a larger assembly, just that complexity is extremely difficult to do if you're trying to do all that in 2D. And it turns out that Creo is particularly adept at helping customers with visualizing and managing the development of very large assemblies. It's not just that Creo can say, open a large assembly quickly. Of course it can. But it's also that Creo helps design engineers get to their design context really efficiently. Design engineers don't need the entire assembly up when they're working on one particular part of the assembly, but they do need to say, hey, here is the area of the design that I want to be working in right now. And Creo has great tools for helping design engineers efficiently tell our system, this is the area I want to work in. Please give me everything and all the detail that I need in this area so that I can get my work done effectively. And it understands how to keep all of that up to date, even though the design engineer is working in a very small part of the design at any one time, right? So really, really powerful stuff working in large assemblies.
Thanks to Brian and to Lorenzo for showing us around D-Orbit's headquarters. Please rate, review, and subscribe to our bi-weekly Third Angle episodes wherever you listen to your podcasts, and follow PTC on LinkedIn and Twitter for future episodes. This is an 1860 production for PTC. Executive producer is Jackie Cook. Sound design and editing by Ollie Guillou. Location recording by Jonathan Zenti. And music by Rowan Bishop.